If you're using a Gavin or Detrum RC transmitter and fly a hangar full of small to medium-sized models, the Detrum MSR66A Sport Receiver is a great choice. Let's take a closer look. As we get started, I'd like to thank Bitco Hobby here in the United States for supplying several of the MSR66A Sport receivers I've used in various reviews. The MSR66A receiver is a great choice for sport pilots as it is small, fairly inexpensive, and has a built-in stabilizer system that's easily programmed using either your radio or the Detrum 3-in-1 programming card. As shown with the Gavin 6C radio, you'll set the mode menu item in the Model Set Function Set menu to Mode Choice and then to the SB switch, which is the only 3-position switch that comes on the 6C. That switch should not be assigned to any other action. The aux1 choice should be set to whatever switch you want to operate your flaps if they are plugged into aux1 receiver port. In a newer version of the transmitter instruction booklet, the Model Set Function Set mode choice shows FMOD for flight mode. Choose this if that choice is available. In the Model Parameter menu, in the Auto Stabilizer Set menu, the switch set choice will be your mode choice, either SB or FMOD, depending on your radio's firmware. You can then select the gyro mode you want for each switch position. Frankly, I'm a little perplexed as to how aux1 channel can carry 2 signals if that's indeed what's happening. The instructions say to assign the 3-position switch to aux1 for the stabilizer control, while at the same time you can assign aux1 to another switch to control flaps, for example. Regardless, it seems to work. Like many of the receivers in the Detrum line, the MSR66A has a 32-bit ARM processor, a diversity-style antenna, and 2.4 spread spectrum scheme that is a combination of both direct sequencing spread spectrum and frequency hopping spread spectrum. Say that 3 times fast. What sets this apart from the RXC receiver line is that the MSR66A has a built-in 6-axis gyro system. That system has 4 modes that are controllable from the transmitter. The 4 modes are gyro off, normal mode, aerobatic mode, and auto recovery mode. You'll have to decide which 3 modes you want active on your plane, as the gyro is normally assigned to a 3-position switch. Let's take a quick look at each mode. First is gyro off. As you'd guess, this setting turns the gyro sensor off. I like to use this setting on each of my planes. This allows you to disconnect the gyro if something goes wrong. This is especially important when setting up the gyro. I usually take off with the gyro off, and then after I have the plane trimmed, I turn the gyro on to validate my settings and rates. If I've messed something up, it's easy to turn the gyro off, land, and make some adjustments. The next mode is called normal mode. This is your basic windy day stabilizer mode. With the proper rates and settings, the stabilizer will quickly adjust to bumpy air to keep your model flying smoothly. This mode does a great job of relieving you from constant inputs on windy days. The third mode is called aerobatic mode. In this mode, you can put the airplane into an extreme attitude and release the sticks. The gyro will lock the plane in that attitude, making it easier to do some extreme aerobatic maneuvers. For example, with the aerobatic mode engaged, you could pull up into a nose-high hover and let go of the sticks. The plane will remain in that nose-high position. Stick inputs will allow you to fly the plane normally. The final mode is called auto recovery mode. This mode will lock the airplane's attitude to straight and level. This mode can be used as a panic mode when you lose control or orientation. Once activated, the plane will return to wings level, assuming you have enough altitude to complete the maneuver. Personally, I normally use gyro off, normal, and auto recovery modes when programming the radio's gyro. As easy it is to program the gyro, though, choosing the best mode that meets a particular flight's requirement is a snap. There's nothing that says you have to keep the settings all the same all the time. Let's take a quick look at the binding and programming process using a Gavin 6C transmitter. So at this point, again, working with the propeller off for safety reasons, I'm going to bind the receiver. We've got it plugged in as the receiver instructions ask for, and then it says to press the bind button, and I'm just going to use the tip of my screwdriver for 2 seconds until it starts to flash slowly. So I don't know if you can see that. Let me see if I can move that so it's better viewed in there for you. And so it's flashing slowly, the little LED. And then it says with the transmitter within about 1 meter, and usually too close is not good, but too far is not good either. So I've got it about 2.5 feet away. I'm simply going to turn on this Gavin 6A. Okay, so I've got the radio up here by the receiver so you can see two things that we look at. One of them is the color of the LED there on the receiver, and then the other is the position of this switch. This is the 3-position switch on this Gavin 6A that controls the flight mode. You notice it's green, and so the switch is fully back, and the green indicator means that the gyro is off. The second middle switch, you can see that the light turned blue, and that means that the receiver is now in the normal mode, which means that it's going to give you some stability help up there when you're flying. So if the wind knocks the airplane around, the controls will move automatically to recenter the airplane. And then the switch fully toward you changes the color of the switch to kind of a blue-green or a light blue color, and that's the auto recovery mode. So if you were out there, you got it totally discombobulated there with what the airplane was doing, you could flick this switch, and given enough altitude, the airplane would return to straight and level flight, at which point you could put it back to normal and resume flying the airplane. So that's kind of your emergency switch, fully towards you. Straight up is normal with the gyro on, and straight back is off with just the receiver working as a normal receiver without any stability augmentation. So here we are with the Gavin 6C, and there are a couple of things I need to point out before we jump into the programming. There's a couple versions of firmware out there depending on how old your radio is. This is a bit older version of the Gavin 6C, and so some of the choices that I'm about to show you are going to differ. The other difference is in the manual. The older manual, the version 1 manual, on page 39 has some helicopter explanations, but on the newer manual, version 1.1, it has some explanations about the flight controller. And so download version 1.1 because that's where you're going to get some information that'll help you program the flight controller that goes beyond what's in the MSR66A instruction sheet. So here we are in the main screen. We're going to be using the Dynam Cessna 182 model. So we'll move into programming mode. And so we're going to move then to the model set choice. So we're going to go down to model set. And then we're going to go down through the choices, and we're going to go to number 4, which is the function set. And we're going to enter function set. And then we're going to go up to, again, menu choice 4, which is the mode set in this. It might say flight mode in your software. So we've got that. And you can see I have it set to choice SB, Sierra Bravo. So it's switch B on the top. It's the 3-position switch on this Gavin 6C. I can make other choices, But if I move to one of those other choices, it's only going to be a 2-position switch, which will allow the flight controller or the stabilizer in your airplane to only be on in normal mode or off. So I'm going to set that to SB. Now, if you have the newer firmware, you're going to have an FMOD choice, so FMOD. And if you have that choice, that's the one to pick. So with that selected, we're going to move down to aux1. Now, this is where it's kind of interesting because, you know, you're thinking aux1 is the control channel for the receiver. That's not the case. So we can set flaps on aux1, and this Cessna 182 has flaps. And so I have used the switch here, and I'm going to choose switch SD to control my flaps on this radio. I want to make sure I don't use switch SB because the controller's on that one. So I'm going to use a 2-position switch. I can have the flaps up or the flaps down. And so those are the two things in the model set menu that we need to change. And so we've got those set. We'll back out. Now, in this case, we're going to move up to the model parameters menu. So in the model parameters set, you'll notice that there are little dotted lines before the arrow. So let's go into that. So we're going to start here at the top of the list. We're just going to move our way down. And this time we're going to move down to the choice number 9, which is the auto stability set. We'll enter choice 9. And then we're going to go into switch set, which is choice number 1. And on switch set, you can see at the top here it says switch SB. That's because I set SB in the mode switch. Now, if you had flight controller or flight mode and you chose FMOD, you would see the word FMOD there at the top of that screen. Now, we've got the choices for the gyro off, on, auto recovery, and aerobatic, and we use the up and down buttons to choose those choices. I like position 1 on my 3-position switch to be gyro off. To make the selection for position 2, I move it to position 2, and then I can make the choice. Again, I want normal, and position 3, I like that to be auto recovery. These are really easy to change, so if you're going to fly an aerobatic mode one flight, go into this menu, make the change. It's easy to do. We'll back out of this. Next, we have 3 choices: roll gain, pitch gain, and yaw gain. Each of those works the same way, so let's look at the roll gain choice. Now, the first choice is direction, and frankly, I haven't found any difference in normal and reverse, but it's there. If it's moving the wrong way, this would be the choice to make. Now, the angle gain is not degrees, but it's a percent, and so the default is 50. And so when the airplane moves and it reaches like that 50% gain or that input from the gyro, it'll start making an input. If the airplane starts to waggle its wings back and forth like this, that's an indicator that this angle gain is too high. And so you can see I've taken the angle and rate gains both down to about half that to see if I get a little bit smoother flight and stop the wing waggle there. These numbers do not have to be the same, and so just work with them until you find the settings that you appreciate, that works best for you. Again, they work the same for roll, pitch, and yaw. Now, the roll offset and the pitch offset are 2 numbers that have to do with how the receiver is mounted in the airplane. And so if you have the receiver mounted at a bit of an angle, or if when you're flying you find that the airplane flies with a bank to the left or the right, or flies nose high or nose low, these controls will help tell the stabilizer what is level. So for example, on one of my tail dragger airplanes, I have the pitch offset set to about 5 because when it's sitting on the ramp, when it initializes, when I plug it in, it has some pitch up because it's a tail dragger. And so with 5 set, it flies nice and level. If you were in a cockpit where the receiver had a bit of an angle to it, you know, the mounting surface was angled just a little bit, you could put in some roll offset. Again, the way you're going to know that is when it flies to the left or to the right, when you've got the stabilizer on and the sticks centered. So you can see you can add minus offsets and you can add positive offsets to the offset controls. The last thing we're going to talk about for the receiver is mounting. And so we've got the mounting up. We can mount this right side up, which is what we've got in the Cessna 182. We could mount it to the bottom of a wing, in which case we would mount it down, so it was upside down, and we could mount it on its right side or on its left side. Again, that'll help the gyros know which way it's pointing. So in this case, I've got it right side up and I have it set that way. And then I go down here again in the flight controller. I've got a normal wing. It's a straight wing with ailerons and flaps. We've got choices for delta wings and V-tail type airplanes. And so that's going to impact, of course, the signals that go out to the various flight controls. So this is a normal wing, and so I've got set for normal. And those are the choices in the flight controls. We're going to back out of flight controls, back out of airplane parameters, back out of the menu settings, and now we've got everything all set. We're ready to go. And the MSR66 receiver and stabilizer are ready to take up and do your test flight. Be sure to use the double-sided tape. Velcro or other mounting techniques may cancel out some of the movements the gyro needs to sense to provide good performance. It's important to know that the MSR66A is a full-range receiver. I fly several planes equipped with the MSR66A receiver at my RC club field and have not had any signal loss issues even at fairly extreme ranges, at least extreme for a 1200 to 1800 millimeter wingspan model. This receiver does not support telemetry. In other words, by itself, it won't report the various airplane performance variables. So, there you have it. Just about everything you need to know about the Detrum MSR66A Sport Receiver. If you found this video helpful, please smash the thumbs up button below the video and subscribe to the RC Planeviews channel. Click the bell icon to be notified when I post new videos. Thanks for watching.